In this video, we're going to talk about the future value of an annuity. So let me explain these terms. It's very important that you understand exactly what I'm talking about when I say the future value of an annuity. So here, time zero is today. An annuity, just like with present value, the same thing. Is going to be a certain payment for a certain number of years or months or weeks or whatever. So we're going to say $1,000 a year for 3 years. So the question, and this is going to be at 10%, the question is, if you had a bank account that earned 10% and somebody gave you $1,000 at these times, how much would you have at time 3? So the question I would say is, what's the value at year 3? Well, the $1,000 that's put in the bank at year 3 is worth $1,000. I'm going to write it this way. $1,000 times 1.10 to the 0 power. Anything to the 0 power is 1. So it really doesn't matter, but I just want to point out it's in there for 0 years. This $1,000 is going to be worth 1,000 times 1.1 to the first, because it's in there for a year. This $1,000 is going to sit in there for 2 years, so it winds up being $1,000 times 1.10 squared. So this is equal to 1,000. This is equal to 1,100. This is equal to 1,210. So I add them up, and that's worth 3,310. So you see, individually, I take them together individually. The payment that you get 2 years from now winds up being worth 1,100. The payment you get a year from now winds up being worth $1,210 if you were to take it out of the account at year 3. So the question is there a faster way, a better way to do this? And the answer is yes. We have a formula, a little graphical mathematical content coming up, sorry about that. So the future value of an annuity with n payments is going to be equal to the payment times 1 plus I to the 0, right? This first one's 1 plus I to the 0, plus the payment times 1 plus I to the first, and this keeps going, but the last payment is multiplied by 1 plus I, not to the n, but the n minus 1, right? Because just 2 years. So again, we're going to use the same trick. Let D equal 1 plus I. And I'm going to move this up a little bit so we can take a better look at it. So the future value of an annuity with n payments is equal to the payment times d to the 0 plus the payment times d to the first plus however many we have, but the last one is going to be the payment times d to the n minus 1. Another way I could write that is payment, pull that out, and that would be d0 plus d to the first plus all the way up to d to the n minus 1. And the same little mathematical trick, not really trick, but the method here, multiply both sides by d, and I have payment times d to the first plus d squared plus all the way up to d to the n. And now if I take d times the future value of the annuity and subtract the future value of the annuity, what am I doing? It's going to be, I'm taking all of these d's and subtracting them from those. So the d1 goes away, the d2 goes away, but what is left is this. I'm going to have the payment times d to the n minus d to the 0. So if I factor out the d here, the future value of the annuity is equal to the payment times d to the n minus d0 over d minus 1. So if we move that over here, the future value of the annuity is equal to the payment times 1 plus I to the n minus 1, because d to the 0 is equal to 1, and d is 1 plus I minus 1. So the future value of an annuity is equal to the payment times 1 plus I to the n minus 1 over I. So if your calculator wants to find future value, it's going to look something like this. And let me redraw this timeline. We have 0, 1, 2, 3, $1,000, $1,000, $1,000. And the question the problem asks is going to say, what's the value at year 3? Okay, so you need to know the size, timing, risk of the cash flows. There are going to be 3 cash flows. They are $1,000 each. They're 3. N means how many payments. It's important. N means how many payments all the time. So how many payments are there? There are 3. The payments are $1,000 each. Present value is 0 because the calculator is set up to say one particular problem. Future value is going to be the value when the payments end. That's the equation that we just derived. Future value is defined as when in the future, the day the payments stop. And present value is what is there at time 0. There's nothing there at time 0. And present value really means what's there the one period before the payments start. There's nothing there, so you can put a 0. The interest rate is equal to 10%. You plug that into your calculator, you find the future value, and you need to write that's a value at time 3. That's equal to $3,310. How did your calculator do that calculation? It did the following. It said the future value of the annuity with 3 years is equal to the payment 1,000 times 1 plus I, which is 10% raised to the 3rd power minus 1 all over 0.1. So that's what your calculator is doing. It's very important that you keep in mind that's exactly what your calculator is doing, because we could have something that would be a little different that's going to look like this. So here, what if I tell you you're going to get the following cash flows? They're going to start in year 1, and there are going to be 3 of them. But the question is not what's the value at year 3. The question now is what's the value at year 7. So if you get these cash flows and you keep them in the bank earning 10%, how much will you have after 7 years? You know it's going to be more than what you would have to have after 3 years, right? So this is going to be a 2-step problem. Step 1, n's equal to 3 because there are 3 payments. Present value is 0 because there's nothing in the year before the payments start. The payments are equal to $1,000. The interest rate is equal to 10%. So you put that in your calculator, and it tells you the future value, and the calculator has no idea what you mean by future value. It says that's when the payments stop, when the last payment is. So that's the value in year 3. That's not what you're looking for. You're looking for the value in year 7, but we know the value in year 3 is 3310. Step number 2, the value in year 7 is equal to the value in year 3 times 1 plus I to the 4th, because I'm going to go, here's 4, 5, 6. I'm going to take these values, I'm going to say, and this is important to think about, I don't care if you give me $1,000 a year for 3 years, or if you give me $33.10 at year 3, or if you let that sit in the account for 4 more years, at $33.10 times 1.10 to the 4th is going to be equal to $4,846.17. So that's the value in year 7. Right, so last thing here, you don't care which one of these payments you get. You don't care if you get the 3 payments of $1,000, the $33.10 in year 3, or the $48.46.17. What we're trying to do with all of this is see, I'm indifferent between receiving these different cash flows. The value of those payments, the value of these payments to me at year 3 is $33.10. At year 7 is $48.46.17. Alright, that's it for future value annuity.